Hi guys, Arthur D here. So in the last couple of days I've been building a few of these awesome Hairball 1176 units, which they rock by the way. And in the process someone on my Facebook asked me how did I manage to do the fourth and optional calibration step, which is the total harmonic distortion calibration, and I've decided to make this video showing how to do it. So basically on Hairball's guides there's a mention to do this fourth calibration step. They tell you how what are the test scenario, but they really don't explain you how to do it. They just tell you you need special equipment, and if you don't have it, just leave it how it is, because it wouldn't affect much the overall sounds. So the idea of this test is to reduce the total harmonic distortion to minimum levels, or if you prefer, just to tune it to taste. You do your audio tests and you just put it on a level you think you like it more. It's really important that you have done the other calibration tests before. The first, the second, and the third step. The unit has to be 100% calibrated, and also you need it to be warmed up at least a couple of hours, so all the electronics just fall in place and are working correctly, or you might have problems. Okay. The idea of how to perform the test is just you input a 500 hertz signal at a certain level, which is 24 millivolts. If I'm not mistaken, it's around minus 30 dB, and you put also the output around 0 dBs, and you do a real-time analysis on the frequency response, and you find out what's the current total harmonic distortion, and you just fine-tune this trim pot, which is called this trim, until you reach the minimum distortion. Okay. Initially I tried to do this with my oscilloscope because it has those functions, but I didn't like very much. The precision was not very good, and it was giving me some weird measurements, so I decided to find another way, which I found out it's really the best way, and it's really precise. So basically I just got my studio converters, which in my case are some Focusrite Red Nets. They are 24 bits, very good precision. I used the Room EQ software, which you can get it from Theater Check forum, if I'm not mistaken. And Room EQ has all the features. You have the signal generator, the meters, and also the real-time analysis with the THD measurement. And I just use those to perform this test. So now I'm going to show you how to do it. What you want to do first is just you have your input and output. You want to hook up your multimeter in AC, okay, and you need it to read on the inside of the XLR pin 2 and pin 3 of the input. And you really need to do this because as you should know by now, the 1176 has a very low input resistance. So if you measure it, the input level without being connected to the 1176, what happens is that once you connect it, the level will drop. So you really need to do this with everything connected. Okay. For the reference test scenario, you need the input to be fully clockwise, okay? The output around 18, and the idea is to put this on around 0 dBs. That will show you how to do it. Attack off, sorry, okay, fully counterclockwise. Release fully clockwise. Ratio 20:1, and in gain reduction mode. So this you can get from the Hairball site. It's there, okay? To generate the signal, I'm going now to show you. See if you can see it. I use room EQ, okay? You can configure it. What I did is just went to preferences. I have an Avid HD native, so I use the ASIO driver. I select has my output, output 1, input 1, okay? And now what I do is I just grab the signal generator, okay? Screen is too big for the iPhone. So you generate a 500 hertz sine wave, and you dial in the level. I have here my cheat sheet. So for you to get the 24 millivolts, at least with my setup, with yours will be different, of course. You have to try it out. It's around minus 49.23, and although it only shows 1 decimal place, you can work with the 2 decimal places to fine-tune the level. And you just look at your, oh, I forgot one thing, just hit play, okay, and okay, I'm very close. Oh, it's there. Okay, so 24 millivolts AC, and now you need to make sure you have around 0 dBus, which is more or less minus 18 dBFS. For this, what I use is I just get the level meter here, okay, and currently I have minus 20. I will just change the output knob until I have around minus 18 dBFS. Okay, guys, sorry, just ran out of space on my phone. So we were generating 24 millivolts signal, and we were inputting around 0 dBs, minus 18 dBFS. So the output knob is around 18.5, and what you want to do now is just run the real-time analysis. You can close this, and okay, you have it here. And what you want to do is set the, I found out that the FTT length around 16, try to focus, 16,384 gives a good precision compromise. And also I use the window Blackman Harry 7, and you just can close this, start recording, and software starts to analyze it in real time. Let me close here this window, we don't need it. And what you need is just run the distortion meter, okay, and what you want to be looking at is the THD plus noise, which currently is around 0.12%. It already started to identify the harmonics. You have here the 500 hertz, the second, the third, the fourth, the fifth, and so on. Okay, so now the idea is just you get your key and you trim the pot until you find the best, the sweet spot for the distortion. So I'm going to start trimming. Let me just, sorry, it's not easy to do with both hands. Okay, and I'm now turning counterclockwise, and it's reducing. So the idea is, in this case, if I went clockwise, it would increase the distortion. So I'm going in the right direction, and this has a sweet spot. So just wait a minute, just lost the grip. Okay, so you have, I was saying, you have a sweet spot. So the minimal distortion is not on the end of the wiper, so you need to find it. 773 7772 0071. Okay, 70. I think we got to the bottom. Yep. Now just getting worse. Okay, I think it's about it. So 0.7%, which is not bad. So this is the idea. I hope you find it useful and just try it out. Okay, cheers, thank you.